In this video, we are going to graph a system of quadratic inequalities, which sounds kind of complicated, and it's not simple by any means, but it's just graphing one quadratic inequality and another one on the same graph. So I'm going to start by, just for clarity's sake, I'm going to have the top inequality, I'm going to graph that in red, and the bottom one I'm going to graph it in blue. So I'm going to pick one to start with. Really doesn't matter. They're both set up nicely in the sense that y is already isolated. And you can treat this top one as either standard form or vertex form, whichever one you would like. I'm going to treat it as vertex form, because if you remember vertex form, looks like this. Since it's just negative x squared, my a is -1, my h is 0. So my vertex for the red one is 0, 9. The reason why I can quickly say 0, 9 is if I plug in x is 0, the x squared part's gone, all that's left is a 9. So I've got 0, 9, which is all the way up here. Okay, I know based off of these symbols that everything's going to be solid. I don't have any dash parabolas this time, which is kind of nice. But now I'm going to make an xy, ay table for the red parabola. Remembering that my a is -1 in this case. So left one, right one. When I square those, I get 1, multiply it by -1, it's back to -1. If I had plugged in -2 or +2, squared to get a 4, multiply by -1 to get a -4. So left one, down 1. Right one, down 1. From the original vertex, left 2, down 4. Down right 2, down 4. And I can actually keep going, and I'm going to on this one. So the reason why I want to keep going is because I kind of don't know where these parabolas are going to end up next to each other, so I want to cover as much of the grid as I can. So if I went left 3 and right 3, I'm going to end up going down 9. So left 3, well, down 9 that's going to be my x-intercept. Okay, so I could go left 4, or left 4 and right 4, which is going to end up being down 16 from that first one. So down 9, 10, 11, 12, 13, 14, 15, 16. I could keep going if I wanted to, but at this point I have a strong idea that it's not going to end up on my graph anymore. So I get my solid parabola. Now there's going to be a lot to do in this problem. It's going to be easy to forget to shade something. So what I'm going to do is I'm going to do the work for where to shade, but I'm not actually going to shade it. And after I finish the problem, I'll go back and show how messy it could have been if I had done that. So in the red, I'm going to use my test point of 0, 0. Okay, my axis of symmetry is x equals 0 in this case, so that's kind of nice. If I plug in 0 equals 0, 0, 0, y is 0, less than or equal to -0 squared plus 9 is 0 less than or equal to 9. This is true. So I know that I'm going to shade below the red. Okay, now I write kind of big, so I'm going to jump to the other side to do my work for the blue. For the blue, it's in standard form. -b over 2a gives me x equals -2. So x equals -2 is my axis of symmetry. Think of it as y equals -2 squared plus 4 times -2 minus 6. Just plugging that into the inequality gives me 4 minus 8 minus 6. Well, that's not negative. Yeah, that's -10. So 4 minus 8 is -4, minus 6 gives me -10. So I'm going to have the ordered pair of -2 and -10, which is all the way down here. I had to do more work to find the vertex because it was in standard form. I'm going to do the same idea of x, y, a, y. 1, -1. This time my a value is still just 1, which means this ay piece, if I notice immediately, is just going to be the y column. So I don't really need to write both necessarily, but right 1, up 1, left 1, up 1. So I can just say, square it to get a 4, can jump all the way over the side if I want to. If I feel like I'm going to make a mistake, I can still fill in the middle and find that right column. So over 2, up 4. We see that the blue is already crossing part of the red parabola, but I want to keep going as far as I can. So 3 to the right or left, and then up 9. It's going to be there and there. Now I'm going to go right 4, up 16. I'm not going to be able to go on the graph any further. I can connect my dots. This one is solid. So I get that blue parabola. I don't really like how that one ended, so I'm going to retrace that because I don't want my parabola pointing in on itself. Should always point out a little bit. I still need to use a test point. I'm going to use the test point of -2, 0. Okay. I'm using that because I know what happens when I plug in x equals -2, I get a -10. So I'm going to have 0 from this test point. Is that greater than or equal to the -10 I find when I plug in -2? This is true. So both of these things are true. So what I had to have done, if I had shaded right away, I would have shaded all of the stuff inside in red. Then I would have had to try to ignore that shading to graph the blue. Then I'm going to have to shade all of the stuff inside of the blue. And that's kind of hard to see what you're doing when you're graphing. So what I like to do is figure out where I'm going to shade. So I know, based off of this red stuff, that I'm shading inside the parabola for the red one. And I know based off of this one that I'm going to shade inside of the blue when I'm shading for the blue one. Now, I need to shade what's shaded twice. That's where my solutions are. So the area that's inside the red and inside the blue is this section right here. This is where my solutions are. Okay, those are all of the ordered pairs that make both inequalities true. Graphing a system of inequalities is probably the longest problem that we will have to do in this chapter. There will be word problems, but I do think graphing systems of inequalities take more time. Don't try to rush through it. It's going to be very simple to make a mistake, whether it's having a solid line versus a dashed line, or losing a negative sign, or shading on the wrong side, or something along those lines. So make sure you take your time with it and are very confident in all of those little details. Have a great day, everybody.